Hello everyone, my name is Robert Salinas and I'm going to talk about critical path-based linear scheduling in construction projects for the class of Advanced Construction Scheduling imparted by Dr. Mohamed Del Rahim. Construction projects tend to feature similar units in which activities repeat from unit to unit, requiring schedules that ensure the continuous usage of resources and consistent network logic between concurrent activities. This video presents a scheduling procedure for critical path method, CPM, in linear construction projects with repeating activities that simultaneously allocate the resources without interruption, while preserving relationships between successive units. This procedure also represents activities by variable production rates to consecutive units, assigning a lag time and determining critical units into two categories, logical and resource critical units. The CPM shows the dependency relationship between activities. It detects the critical activities, reveals the fraud times, and gets the minimum project completion time accordingly. It's the most convenient means of scheduling, analyzing, and controlling activity networks. Multi-story buildings, highways, and pipelines are some of the examples of linear or repetitive construction projects that require the implementation of a set of activities similar to from each other that keep repeating and repeating. Scheduling of a linear construction project requires the uninterrupted usage of resources between similar units and enable timely movements of crews from one unit to the next. The maintenance of work continuity leads to advantages such as the minimum idle times and each crew member having a maximum learning curve due to the familiarization with the equipment. It also slows the minimum movement of a project, the movement of equipment, which is cheaper not to move the equipment. This is the methods that we're familiarized with from the lecture, which we know very well, the bar chart, the arrow diagram, and the precedence diagram. This is the one this video focuses on, which is linear scheduling, which I'm going to explain at the end of the video. I'm going to talk about the advantage, about the rivalry between the two methods and which one is better in which things. So the VARSAR and CPM have received criticism for its inability to maintain work continuity with linear projects. It's also very deterministic in that this technique assumes the limited availability of resources in the initial development of the schedule, which in real life they tend to need adjustment all the time due to resource limitation. The most important feature of CPM is the ability to specify critical paths which identify the activities which can cause a delay in the project completion. The linear scheduling is the most convenient method for scheduling and controlling projects with very repetitive units. Unlike rival methods stated before, it provides the work continuity between the same activities of successive units in accordance with the resource availability. It also is very smooth and efficiently in the flow of resources, requiring less preparation time, which is one of the main advantages of linear scheduling in comparison to CPM. However, it also must tell the critical activities in order to be accepted as the previous methods. I want to talk about the history. The idea of repetitive scheduling originated in manufacturing engineering with mass production lines and workstations that kept doing the same activity for mass production in the 1940s. It was used for production control with the objective of evaluating the productive rate of finished products in a production line. In the 52 and the 60s, it was further developed by the US Navy. Then it wasn't until 1968 that it came to civil engineering, when the National Building Agency of the UK used it for repetitive housing units, and the engineer that used it first on literature, his name is Lumsden. It appeared further in literature in 75, 81, 82, and 89. Determining the critical path in a CPM is crucial. It helps in controlling and updating the original schedule. In recent history, in 98, Harmonic and Rolex introduced a method, the linear scheduling model, that identifies the controlling activity path to a linear schedule based on time, distance, relationship, and activities. It's very similar to CPM. Ten Harris and Liu used a similar approach, but they call it repetitive scheduling method. Amar and Elbertagi in 2001 introduced an algorithm for determining the critical path considering resource continuity. In this one, the production rate of each activity is compared with that of its successors in order to specify the start-to-start and finish-to-finish relationships between two consecutive units. However, this one assumes constant production rates and it only can consider the finish to start and start to finish relationship ties between the activities. The aim of CPM is to find out the critical activities and compute the shortest path duration to finish the project, considering the logic and resource availability constraints. In linear scheduling, however, not only logic and resource availability matter, but also the continuity of resource usage of the four ends: manpower, money, machines. For this reason, the proposed CPM-based linear scheduling procedure executes CPM's forward and backward path calculation, but this one uses the network logic and resource continuity. In the other one, the resources don't matter. The formula that we use allows to represent the repeating activities where variable production rates along successive units. The formula used is Ri, n equal to 1 over Udi, n times 1. Production rate of activity I, which the number n of production rate, Udi is the unit duration. The present relation between activities are required. The activity duration of units are required. The number of successive units are required. So this is how the calculations are done. So it uses the forward pass and the backward pass by the precedence diagram, but this one does it in a different way, with a different set of equations. So we set the early start and the early finish in unit 1. Then we add the unit durations UD1, UD1, 1. So then for the unit 2, we go early start, early finish, 1, 2, UD1, and we do this on the first one. And then, it could last 30 units, let's say. So we just use n number until whatever is the last number of days required. We set the late finish. Okay, we're talking about the backward pass now. So it's similar to the other one, but it's backwards. We start with the final activity in the forward pass, and then we go backwards. So we set the late finish to the KT activity, to the end number, which end is a template for whatever is the last number in the sequence, and then we go backwards all the way to activity 1. So we can see late start, late finish, and then we replace that with early finish minus UD. Then it goes like that. I'm not going to explain everything because of time constraints in the video. So this is how the second part looks like. So we have the stage 1. And this is how it goes after the second activity. So it goes early start, early finish, early start, early finish, all the way to the unit end of whatever is the activity. In some cases, this one is how we will do it if we were considering lag. So this is if it were finish to finish. We have the early start, finish, and we are considering minus the UD2, early finish, and plus the lag. So we do all the way to the end. This is how we do the dummy activities in the linear scheduling. So an arbitrary activity in the network ACT1 may be dependent on, more than one activity is when we need a dummy that we do on the precedence diagram. It's the same thing. So for finish to start, we have the late finish, which must be smaller than the late start minus lag. We have the start to start, and in this one, the late finish minus the UD1N must be smaller than the late start minus lag. And I'm not going to explain the rest because of time constraints, but you know how it works. This is how the backward path looks like. So we have the finish to start case, where early start must be bigger than early finish plus lag, and early start must be bigger than early start per lag. And I'm not going to explain everything, but this is the relationships. So this is the Excel of the example that is done on the research paper about this video. So you can see this is the initial information, and it has A, and it tells you if it's a finish to start relationship, and posterior will be posterior lag. So you can see the forward pass here, and it does the activities, and the red one I believe is the critical path, and same for the backward pass, which you can see 40 to 44, 44 to 48, 48 to 81. So this is how a linear scheduling diagram look like. I'm going to spray. However, this one is not using the same numbers, so I'm going to spray with the example that is using the same numbers. So this is how it looks like without the implementation of CPM. When we implement the CPM, This is how it looks like. And you know, logically, critically units. This one, the brewer line with the arrows, is the one that tells the critical path. So I'm following all the critical path here. So resource critical units, this one doesn't matter that much. As you can see here, we have the unit number. You can see the unit number is 4. So this one acknowledges for the numbers with CPM-BASED. It also acknowledges at the same time for days. So you can see A is critical path all the way to 4 units. And what you will say is 18 days. However, B4, this one is B4 units, this one isn't critical, only this path. So it's done on Excel. This is what they did on the Excel charts. I couldn't do it because the calculations, as you can see, were too complex. You can see that it acknowledges the early start, the finish, the start relationship. So the advantage of linear scheduling construction projects that is constrained the repetitive units with identical activities. It is possible without ignoring resource continuity and network relationships between activities. The amount of data required to execute the procedure is not much different, that CPM is not much more. Further procedure only requires the number of units and varying activity durations or production rates per unit. It also allows to use any relationship types among the start to finish, finish to start, and the other two. It also enables assigning lag times, which is good. Enables the analysis of and identification critical activities and fault times of non-critical activities and clarifying an unit-based criticality of activities. It determines the relationship between units. And you can also use the bar charts. I mean, you can do it with these values, and you can also do the percentages with these values pretty easily, which I'm going to explain later. The disadvantage, however, is that the activity should be eligible in both CPM and linear scheduling for both procedure to work. So if it isn't good for CPM, it doesn't work. The computerized form is beneficial due to practical use. It needs improvement in regards to resource leveling and caching issues. However, another disadvantage is that it assumes the number of repetitive units that it's gonna remain constant all the way across all activities using the same group of activities for each unit. However, the units might not contain the number of activities in common with the other units. So it might have different number of activities. Eliminating this will improve the procedure. It also assumes a single crew members per activity, which must be improved because, I mean, multiple crews can be used for activities with variable number of people. The main advantage is an ability to perform the forward and backward pass calculation on a linear project while simultaneously acknowledging for the number of resources that we have. It also allows any kind of dependency relationships between finish to start, start to finish, and lag times. Furthermore, it enables the usage of variable unit duration and production rates for activities from one unit to the other. It also allows to determine the fault times, which we can see here, and it determines the critical activities to unit by unit approach. And that's it. Thanks everyone. Have a nice weekend.